Good morning friends. In this video we are going to see how to give a circuit connection in a breadboard for a single stage CE amplifier. You can see the circuit here. That's a BC107 is here. The transistor is BC107. It has three terminals: emitter, base and collector. We will start. So this is BC107 transistor. How to identify the terminals? We can identify using this tag here. So this terminal is emitter, this is base and this is collector. So you can position such a way that this tag appears towards your right. So this is the right side, you can see a tag here. This is emitter, this terminal is emitter, this terminal is base and this terminal is collector. You can position your transistor like this. Now, so this entire line act as a emitter point, this entire line act as a base point, this entire line act as a collector point. The next thing is, so this is the circuit. We will start one by one. Let me tell this is emitter. So this whole line is going to act as a emitter and this is base. The center line is going to act as a base and this is collector. This line, the entire line is going to act as a collector. So the first thing we are going to see is this connectors resistor 560 ohms between the emitter and the ground. So this is the emitter, this is the ground. We will take this line as ground. This line will act as a ground. So the resistor 560 ohms is connected between the emitter and the ground. The next one is, so whichever shown in red is completed. So whichever shown in green is going to, it's shown here. So next is the capacitor CE from the emitter to the ground. You can see the capacitor. You can see this is the capacitor is connected between the emitter and the ground. So as of now we have completed two components. One is the emitter resistor, another one is the emitter capacitance. These two we have connected between the emitter and the ground. The next one is this base resistance, this R2 resistance between the base and the ground. So base is this at the center, this is the base. So you can see the resistance 10 kilo ohm is connected between the base and the ground here. You can choose any of these slots in this line. So now we have connected this base resistance R2 and the next thing is R1 47 kilo ohm. That is also from the base to the supply. So what we will do, we will consider this top line, this line for supply voltage. Later we will give this 12 volt. Now in this photo, we have connected a resistor of 47 kilo ohm from the base to the supply. So this is the base, the center, the middle one. So from the base to the supply, we have connected this 47K. The next is this 2.2 kilo ohm from the collector to the supply. So the collector is here. So this is the 2.2 kilo ohm that is connected from the collector to the between the collector and the supply. Now we don't have enough number of slots. So what I am doing is I have extended the connection here. So I have extended the base connection from here to here. So this entire line will now act as a base. Similarly for collector also, I have extended the collector from here to here. So this now entire line will act as a collector. Now we can see that from the base there is a 10 microfarad. So this is the base. We have extended the base from here to here. So from the base we have connected a 10 microfarad. The next one is similarly there is 10 microfarad connected to the collector. So there is a 10 microfarad here from the collector. This is the collector point we have extended from here. So now we have completed the all the circuit components. The next thing is the supply. VCC 12 volt. So this is a power supply. You can see the positive here and a negative here. So the positive should be, the positive is here and this is the grounded. So negative should be connected here. So what we are doing is, so we have taken two wires here, one is positive, another one is negative. So here you have to give the positive wire and here we have to give the negative wire. So we have completed this portion. VCC is done. The next one is function generator. This is a function generator, is used to generate the input signal. Here you are going to use a sinusoidal signal. This is the function generator. So this is the positive of the function generator and this is the negative of the function generator. So the positive of the function generator should be given to the one end of this capacitor and the negative of the function generator is grounded. So this is the positive and this is the negative. So the positive should be connected to this one end of the capacitor 10 microfarad. You can see here. You can see here the positive is connected to the one end of here. This is a positive side connected and this is the negative side which is grounded. These two wires are from the function generator. The next is CRO. There are two channels in CRO. We can, it's used to view two waveforms at a time. So here we are going to see input and the output at the same time. So this is input and this is output. So there are, you can see positive, negative here, positive, negative, positive, negative. This is for channel 1 is for the input and channel 2 is for the output. So this is for the input and this is for the output. So the input channel 1 should be connected to here. So input channel 1, this is channel 1 is connected to here, positive of channel 1. Here the negative of channel 1 should be connected to here. Similarly, here channel 2, the positive of channel 2 should be connected to here, the negative of channel 2 should be connected to here. You will see this. Positive of channel 1. This point we have connected here and the other point is grounded. So now we have to take from the channel 2. You can see here. This is the positive of channel 2 is taken from here and the negative end is grounded. Now we can see the function generator. You can switch on the function generator. You can set a frequency. You can adjust this knob to change the amplitude. Adjust this knob to change the frequency. This Fn is a function where you can set sinusoidal, triangular, different waveforms are here. And this is the multiplier to change the scale of the frequency. Now here it is, keep some frequency here and make it a sine wave. Then in the CRO, you adjust the amplitude knob in the function generator so that you can see the sine waveform between these two lines. So it is 1 unit. If you see the height, it is 1 unit. And if you set here, I want to set an input of 20 millivolt. Bin should be 20 millivolt. So you can see this knob here. This is for channel 1 knob. Rotate it and set as 20 millivolt. You can see a 20 millivolt here. Turn around this knob and set near to 20 millivolt. So adjust the amplitude, but adjust the amplitude knob in the function generator and set such that the waveform is between this 1 unit. So it is 1 multiplied by 20 milli, that is equal to, which is 20 millivolt. Now the amplitude is 20 millivolt. Now on the power supply and set to 12 volt. Already we have given the connections. Now just set to 12 volt. Now we can see the output. So to view the input and the output at the same time in the CRO, press this dual. This is dual, which is helps to see the both the input and the output at the same time. This knob is used to adjust the input, which is channel 1. This knob is used to adjust the output, which is channel 2. Now, so you can see the input and output waveform together. This is the input and this is the output. We can see the 180-degree phase shift also. Now in function generator, change the frequency of the input signal. So for various frequencies, you have to measure the output voltage and you have to tabulate that. In next video, we will see how to plot the similar graph. Thank you.